All right, guys, this is another problem. This one's a little bit weirder to understand. You really have to read the context and you have to think of the kind of like what is speed and distance. What's the relationship? Remember that equation? Distance is equal to speed times time. But let's go ahead and look at this. The training facility for a sports club is situated along a straight line shoreline. You row your kayak out 2 miles from the nearest point on the shoreline and then row 6 miles down the beach each day to train for an event that includes rowing and running. If you can row at a rate of 3 miles per hour and jog at a rate of 5 miles per hour, what is the least amount of time required to reach the clubhouse? How far from the clubhouse should you beach your kayak? So this idea that you could go, you want to kayak more or do you want to run more, right? And you're already kind of thinking, well, you could row at 3 miles per hour and you could jog at 5 miles per hour. So you probably want to do a little bit more jogging than rowing. And again, this is kind of like where your kayak is. You're 2 miles out. And then what distance along the shoreline do you want to go? Do you want to go here? Do you want to go here? And so forth, right? That's the main question they're asking. Where should you be to minimize the time? Okay. So the first thing you need to do is you're gonna need to label your variables here. We're gonna say, all right, well, the distance from the shore, we know that's 6 miles, so we could say we're just gonna call this X. All right, this is where you decide to land your kayak and then start jogging. So if this is X, then this little bit here is just gonna be 6 minus X. Okay. And if this is X here, this distance is X, and that's 2, the distance you kayak would be the square root of X squared plus 4 using Pythagorean theorem, okay? So the biggest thing they want you to answer is, what is the least time? So you need to make an equation with time, all right? What is the equation that you're going to use for time? Well, we know distance is equal to rate times time. So we're just going to solve for time. We're going to say time is going to be equal to distance divided by rate. But we have two. We have one for the kayak and one for the jogging. So what is the distance that you're going to travel for the kayak? It's going to be that. The square root of X squared plus 4 divided by the rate. Well, what's the kayak you're going to be doing? 3 miles per hour plus the time needed for the running, which is going to be the distance you're going to be running, 6 minus wherever you land, 6 minus X divided by the rate, which is 5, okay? And that's going to be your function for time with respect to X, and we want to minimize that. So the first thing you want to do is you want to take the derivative of that function, okay? And when you take the derivative of that function, you have to do the square root of X squared plus 4 times chain it to X. And if I simplify that out for you, you're going to end up getting X over 3 square root of X squared plus 4. And you're going to also take the derivative of this next function, which is just negative 1 over 5, okay? If we make that equal to 0, we end up getting 1/5 is equal to 3 over the square root of X squared plus 4. Do a little bit of algebra manipulation. We end up getting 3 square root of X squared plus 4 is equal to 5X. I pretty much just multiply the denominator to both sides on both of them. If I take the square root, or sorry, if I square both sides, I end up getting 9x squared plus 4, right? The square root cancels and the 3 becomes squared, is equal to 25x. Distribute the 9. Subtract 9x squared to both sides, and we're left with 36 is equal to 16x squared. You could simplify that out. You could divide by 4. You get 9/4. And anyways, when you do this, you're going to get x is equal to plus or minus 3/2, okay? Which is about 1.5 miles. And that's it. How far is the clubhouse should you beach is going to be 1.5 because that gives you the minimum time. And if you want to find the minimum time, you actually got to plug that back into your original equation. Okay, plug in 1.5 into the original equation, and you end up seeing that you get about 1.73 hours. Okay, so that's how you do this problem. A little bit weird, but anytime you see a triangle, you're gonna have to do some kind of Pythagorean theorem. And this one was different because it was kind of like the addition of two functions.